Hello, welcome back to another one of our videos. My name is Levi Thomas with Greentec. Today I'm going to show you how to wire up this 50 amp continuous or 100 amp peak JBD BMS, and this is a 7 to 14S BMS. So I'm going to show you how to hook it up in a 7S configuration, which is 24 volts, to this eMatrix battery to power an iCharger, and then use a DC power supply to assist as a UPS. Because this iCharger demands 40 amps, it will run off this battery uninterrupted, and then the DC power supply will then top the battery back up when this is done demanding that power, or in between the charge and discharge cycles. I'll also show you how to wire the same BMS up in a 14S configuration, which is 48 volts, and then 2 more packs on the sides in parallel to double the capacity. And I'll demonstrate using this with a 48 volt inverter as well. So this 50 amp JBD BMS, the blue wire is the battery's negative most contact. And so that actually will reach perfectly to the negative most connection on the battery. And it's a 10 gauge wire, and we'll use a 6mm or 1/4 inch ring terminal on that to connect to the negative most contact. And then also to that same connection is the black sense wire, which is the negative most sense wire. And for that, we've got a 1/4 inch or 6mm ring terminal to a 22 gauge wire. I like to crimp them and solder them. That way there's no room for corrosion or anything like that, or for them to wiggle loose. And then we'll also add heat shrink over it as well. And so with this BMS connected right here to the end, the negative most battery connection will go right here to the negative most terminal. And then these wires are actually long enough to reach all the way to the positive most. We're going to keep all the wires the same length. That keeps the ohm resistance the same, and it gives you a better voltage reading than if you were to cut them at different lengths going all the way along. It doesn't make a big difference. Some people do it different ways, but ideally you want to keep them all the same length. And the wires are long enough to reach all the way, so we're just going to be able to do that without having to really cut any length off the wires or solder any additional length onto it. And then the temperature sensor can go to anywhere, so we're just going to stretch it out and then glue it between a couple cells. And then the C- is both the charge and the discharge negative wire. And it's a common port BMS. That means you charge it and discharge it through the same wire. And again, the blue goes directly to the battery, and that's the B-. So before we start crimping wires on and soldering, I always like to disconnect the BMS from the BMS wires. Then we will start crimping and soldering on the connections and doing the heat shrinking. And then afterwards, we'll hook them all up. And then we will double check with a voltmeter all the connections here to make sure that they're all connected in the correct order. And then the BMS, you're actually supposed to then disconnect it all, hook up the negative most wire first, then with it connected, you hook up the negative most sense wire, battery number 1, 2, 3, 4, 5, 6, 7, hook them all up like that, slowly, and then the positive most through battery wire number 7 are all connected together. We'll go to the positive most connection. So you want to hook them up from 0, 1, 2, 3, 4, 5, 6, 7, so that the voltage increases as it goes along. You're not supposed to hook them all up and then plug it in directly, because if you hook it up and it wiggles wrong and it connects them in the wrong order, it can actually fry out the BMS. Or if you hook them up and you hook up the wrong one to the wrong side and you get them in the wrong order and it's the wrong voltages, it's going to fry out the BMS the very first time, and it's a one-shot thing. So now that I have them all hooked up to each terminal, I've got my voltmeter hooked up to my phone to make it easier for you to see. I'm going to take my voltmeter here, black to the black pin, and then red to this very first pin, and it should be 4.1 volts there, and then it should increase on each one about 4 volts, just to make sure they're all in the correct order. So now this 7th one is 28.6, and then the 8th one should also be 28, along with all of the rest, all the way up to the red wire. And they are. And so now let's check the total pack, which is also 28.6. So now I'll disconnect them all, plug them into the BMS, then hook them all up, the black first, all the way up, and then we'll check it on the BMS, and then test it with the DC power supply and the iCharger. Okay, so now that I plugged the wiring harness into the BMS, and then I connected all of the connections to each terminal, starting from negative to positive. Here I've got the Xiazang Electric app, and I've already made a 10-minute video that's posted on our YouTube about how to program it, how to name everything, and set up all the protection parameters. But here I've got the 24 volt 50 amp eMatrix battery right here at the top, along with all the other ones in the room. But I'm going to go ahead and connect to it. Now I've already charged it up, so it's at 97% state of charge. The total voltage is 28.6, like we saw with the voltmeter. The highest volt cell group is 4.099. The lowest is 4.090 because it balanced when I charged it up. Here's the temperatures of the MOSFET inside of the BMS, as well as the thermistor on the wire here that I've got thermal glued onto a cell, and then hot glue onto each cell, keeping it in place. In this configuration, here we've got 2 batteries in series, upping it from a 7S 24 volt to a 14S 48 volt. And this BMS would connect to all of these battery connections of the 48 volt pack. And then all of these silicone wires are just connecting these two in parallel to these two to double the capacity. This is the way you would need to configure it if you wanted to do 48 volt or 72 volt or 96 volt even, to increase it even higher voltage and 2 in parallel. The downside of doing it this way though is you have silicone wire crossing each other, and you have silicone wire crossing over the bus bars. And while these are coated and the silicone wire has heat shrink and is coated, if they rub together, you have a chance of shorting things out. So that's not ideal, but it's necessary if you were to go to higher voltages. In that scenario, you'd want to add something like a green fish paper, and I'd like to do Kapton tape as well to prevent any wearing and rubbing, to prevent anything from shorting out. However, if you were to keep this as a 48 volt pack, and you know you're going to keep that like that forever, it'd be ideal to put the bus bar in the middle and then the paralleling wires on the outer side. That way you don't have any wires crossing over any metal or bus bars or even each other. So that is the way we're going to do it today. So I'm going to go ahead and take all of these apart and then rewire it in the same configuration of a 2S 2P, but with the bus bar in the middle and then all of the paralleling wires on the sides. And then in that configuration, you could also add 6 or 8 modules, say, all into parallel, but staying at 48 volts. So let's go ahead and take this apart and rewire it in that configuration. So now that I've got these 4 eMatrix modules hooked up, 2 in series and then 2 in parallel, it's now 7S on this side, then connected into series with a bus bar, and then all the way up to 14S, making it a 48 volt battery. And then these two modules on the outside are just paralleled with the inside ones. So the sense wires no longer have to cross over silicone wires that are on the balance leads, and they're not crossing over each other. So similar to how this 7S BMS is hooked up, we've got our black sense wire to our BMS plug hooked up also with our B negative blue wire to our BMS to the negative most contact of the entire pack. And then a large silicone wire balancing most of the current of the negative most side here. And then starting with the first white wire, which is B1, next to the black wire, this goes directly to our first positive connection in this pack. So that's B1. Then the second white wire is B2 connected here, B3, 4, 5, 6, and 7. So the seventh white wire goes to the positive on this side, which is also connected to the bus bar. So there won't be a balance lead on the negative over here because this bus bar is connecting these two together. So you only have the sense wires on the positive connection. So on the negative one on this pack, there's no sense wire here. And then the eighth white wire goes to the first positive connection on these two modules. And then we have 9, 10, 11, 12, 13. And then 14, B14, which is actually the 15th wire because it started with B0, which is black. So the 15th wire, or B14, goes to the positive most connection, as well as a large 10 gauge silicone wire that's paralleling the positive most connection of the entire pack. So that way you have large silicone wires on the very negative most and positive most. That parallels most of the amperage across here. All these are only going to be doing 50 milliamps of current balancing across here. As well as these. So while these are like a 22 gauge silicone wire, went ahead and used 20 gauge silicone wire here as well. And then the positive most connection won't have any connection to the BMS. Because this is a BMS, it only disrupts the negative side here. It doesn't need to connect to the positive at all. It only needs to open circuit to make it function. And because this is a common port BMS, it only has one wire. It charges and discharges through this one negative wire. On the software, we can turn charge on or discharge on or off either way, or we can have them both on or both off at the same time, however you want to do it. So I typically leave them both on at the same time unless there was any reason I wanted to turn one off or one on alone. So now that we've got them not hooked up to the BMS at all, let's go ahead, and here I've got my Fluke voltmeter hooked up to my phone just for this video purpose so you can see it better. And here I'm going to have the plug here. Now this is turned on to voltage DC, and I'm going to put the black probe here on this black wire, and then our first one here. So here we have 3.8 volts, and now if we go down along this, it should increase by about 3.8 a piece in order. And if anything went out of order here, we know we have them hooked up in the wrong order, and that would be a problem, and it would instantly blow your BMS. So that's why we're checking it disconnected. 45, 49, 53. I'm going to go ahead and set this aside. And I'll leave this here just for you guys. And 53 volts. So if we just go along here, we can just verify again that these are all in the same order and the same numbers here. And everything looks to be pretty good. So yeah, everything is just perfect. Exactly like expected. So now, according to this BMS's specific instructions, it says not to plug this in directly here. It actually says to disconnect all the wires, then plug it in, and then go ahead and reconnect them, starting with B0 or the black wire, then connecting 1, 2, 3, 4 all the way along, one at a time while it's connected. This increases the voltage slowly so that it doesn't pop and fry out. If we try to plug this in, even if we tried to angle it and plug it from B0 to the positive, no matter what you do, those pins might not be perfectly aligned, and it might connect a middle one before some of the lower ones, making a large gap of voltage going in really quick. Some BMSs, it tells you to check them all and then plug them in at once. This specific one, for whatever reason, says not to do it specifically, so that's what we're going to do. We're going to disconnect it completely, then plug it in, and then we're going to connect them one at a time, going all the way up very carefully, making sure that we just do not connect a higher voltage one before a lower one or connect them in the wrong order. So I'm going to go ahead and do that, and then we will resume shortly. After I got all this cleaned up, I almost forgot. In this configuration with one bus bar in the middle, you also need a 10 gauge silicone wire on the negative most here, as well as the positive most, and a red 10 gauge silicone here on the positive as well as the negative, because these outer packs are going to have 25 amps going across here and here to the center packs, while 50 amps total is coming out of the whole pack. So let's go ahead and add those now. All right, now that we've finished hooking up our eMatrix battery to our 50 amp JBD BMS, I've got my iCharger 4010 Duo, and it's hooked up to a lithium iron phosphate 12 volt battery that has an internal BMS, and it's not hooked up to any balance wires here. It does it internally, so I'm just hooked up directly to it. And then to prevent a spark, what I like to do, here I've got my DC power supply set to 29 volts and 9.5 amps, but the output is not turned on yet. So I'm going to plug it into the iCharger so there's no spark. Because the capacitors in this are completely discharged, the capacitors in this are discharged. And so I want to hook this one up first, and then turn this on. So now that turned on, that charged slowly the capacitors up in the iCharger and charged the capacitors up in the DC power supply. And then here's our wire from our BMS output. The BMS is currently turned off, so I'll plug that in as well. And so now they're both plugged in together, but this is turned off. So last time we left it, we just charged this up and the protection turned on when it got to the high voltage, because it charged it all the way up to 100%, which shut off the charge and discharge. So under controls here, I'm going to go ahead and clear the warning. I'm going to click yes. And now I'm going to turn on the discharge and the charge function. So here our charge and discharge just turned on. And 8 amps now are actually coming into the battery. So this DC power supply is putting 8 amps into here. So this iCharger, we're just going to run it at lead acid. 12 volts and 30 amps. Because this has an internal BMS, I'm just going to run it like it's a lead acid. The voltage is about the same. And so now I'm going to start charging. And so now this is at 13 volts, 13.4 going out. The amperage is now slowly starting to ramp up. The input volts are at 29 volts, which is coming out of the DC power supply right now. The input amperage is at 9 amps. That's going up to 10, 12, 14, because our output voltage is at 14 volts and 30 amps. The input amperage demand is at 15 amps. So now we've got 9.5 amps coming from the DC power supply. And then we've got here -6 amps coming from our BMS. So most of it's coming from the DC power supply. The rest is coming out of the battery. And the iCharger is functioning perfectly fine, doing its task. And if I were to turn this off, or if this was to lose power or go bad for whatever reason, I can turn this off. Nothing got interrupted in our charge cycle here. So you're not going to run your test. Your test isn't going to stop here. But all of the current here is like 10 amps are now coming, 11 amps are coming directly out of the BMS itself. Nothing is coming out of the DC power supply. Now, if I turn this DC power supply back on, we still have all the amperage coming into here, but now we only have a little bit of amps coming out of the BMS, and 9.5 are coming out of here. And so again, nothing got interrupted with this, whether we turn it on or off. And so our process is going fine. So that's the beauty of having a battery as your buffer to run your iCharger. If you were to run your iCharger straight from a DC power supply that's underpowered, if I was to try to run this at 30 amps, which pulls like 16 amps, well, there just got disconnected. But if I was trying to pull too many amps out of this, this voltage would dip from 29 and it would start going down to like 10 or whatever, and this would be trying to boost its power, which would actually end up frying out the iCharger. And I've done that a couple times. So having a battery as your buffer, it can then run your iCharger perfectly fine without any interruptions. And so now that this is turned off, this is still putting out 8 amps. And again, now all that 8 amps is going directly into the battery and it's charging it back up. And now if we turn that off as well, there our charge turned off, our battery is just sitting idle, our voltages are 4.108 to 4.099 on the low, it's still at 99%, charge and discharge are both turned on, and I can go ahead and manually turn those off if I want to, before I unplug it. I always like to unplug the XT60s first, before I unplug the banana plugs. That way you don't accidentally, with it connected, short out or anything like that. So that's how you can use the BMS on the eMatrix battery to run your iChargers or whatever device you need to do, and then use a smaller DC power supply to assist or to charge up the battery once it's done. So now I've got this 48 volt eMatrix battery configured. I've already got the BMS programmed like I showed you in the other video on our YouTube channel. So let's go ahead and turn the discharge off, and that stops the current flow out. Because of the capacitors in this inverter are discharged, there'd be a large spark. Even though this is an anti-spark XT90 plug, it probably won't handle it. It'd probably pop this plug. So we'll turn the discharge switch off, plug it in, and now we can turn it on. And so now that gives power out to this inverter. And then if we go to real time here, there isn't any current going through yet. So let's go ahead and turn the inverter on. So everything just kicked on here. The current still isn't showing much at all because it's only about 5 watts. And if I logged into this with my phone, I could see that. But this is a 1600 watt heat gun. I've got it set to 5 out of 7. So here we've got it turned on. And I've got it set lower because I've got this tuned down to 15 amps because I've just got a power strip here. But now in this app, we can see it's at negative 16 amps or negative 1000 watts. So that means it's coming out of the BMS. And then here, we can see the MOSFET in the BMS has gone up to 31 degrees Celsius because I've already had this running for about 10 minutes before I shot this video, while the room temperature ones on the battery are down at 23 degrees Celsius or 74 degrees. So 74 degrees on the batteries and 88 on the BMS are super low. And this BMS can handle the 50 amps and it's only running at 18 right now. And even at 50 amps, it wouldn't get more than, I'd say, 20 degrees warmer than room temperature. So these silicone wires are never going to heat up. These plugs aren't ever going to heat up with a 50 amp continuous or 100 amp peak BMS. So that's a great solution for a small 2200 watt inverter. If you wanted to do a larger, like 18,000 watt inverter, you'd want a larger, like 250 amp BMS that JBD makes as well. Or you can get even larger, like 50 amp to 1000 amp JK BMSs that use contactors instead of MOSFETs. Thanks again for watching, and don't forget to like and subscribe to see future videos that we post. Thanks!